Hello, everyone. I hope you're all enjoying this event with Tech in Motion and also learning from amazing panel of all my fellow speakers here. Thank you for joining me in the career workshop today. For this session, we will talk about AI-driven code generation and its practical constraints. I'm excited to explore this topic with you and how AI is shaping software development in general. It excels in some areas, but it also falls short in some. And I want to make sure that you guys have a pragmatic view of the landscape of AI generated code bases and how to use it and what are the common pitfalls to kind of avoid. Um, Brief introduction about me. I am Siddharth Parakh. I have over 16 years of experience working in software and product development, specifically specializing in enterprise and SaaS applications. Currently, I lead product engineering at Medable. At Medable, we develop platforms to transform how clinical trials run today and how AI and digital transformation is making it more efficient. Um, and we are seeing some amazing advancements in general with the advancements of AI. And I'm going to talk about it a little bit today. But all right. So, with that, without further ado, let's dive in. Now, I'm assuming that all of you guys have tried at least your hands with LLMs, maybe generated some code, either for work or for curious explorations. AI-driven code generation has emerged as a game changer in software development. It is promising faster delivery, reduced manual efforts, um, and so many more positive advantages. Today, we'll dive into what it is, how the code generation works, what benefits it offers, and the constraints that developers face today. So my goal is by end of this talk, you all have a balanced perspective on how to leverage this technology effectively. So in the agenda, let's go over and start going into these topics one by one. But what is AI-driven code generation? In simple terms, AI-driven code generation is about using machine learning, right, or machine learning models to automatically write code based on your inputs. Um, this evolution started with basic syntax-based auto completion. So you've been using IDs as developers, and you know the basic auto completion of your functions, your methods, your syntax is basically what was very early stage of it. And now it has progressed to a fact that it can and it is capable of writing the entire function or a whole module even for you. um, there are many popular tools out there. um, Tools like GitHub Copilot and OpenAI's Codex are leading this transformation right now. They're trained on vast repositories of code and understand common programming patterns. And the LLMs are very effective in kind of this pattern generation. So, how does it work? Um, the underlying technology relies heavily on transformer model, um, which excels in understanding and generating tests. Now, today, for the interest of this talk, I don't have much time to dive deep into it. But if you guys don't understand what transformer architecture is, then I would highly encourage you to kind of learn about it, understand the basics of it, so that you can use it properly. Uh, you provide, so how does it work? You provide an input prompt, right? Example, create me a REST API for user management. And the model generates code based on its training. The key strength lies here in the ability to analyze massive data set of existing code and learn the patterns and create code snippets that match your requirements. So it's pretty cool how it works. I actually have a really cool video that if time permits, I'll come back to, where it kind of shows comparison of different models and how they all respond differently to the same query. Some do really excellent jobs, some maybe mediocre, some provide too much documentation upfront and less code. It's quite interesting, but we'll come back to it if we get chance to. Um, so what are the benefits of AI-driven code generation? Um, we sort of touched upon this when I started the talk, but AI code generation offers undeniable benefits. It saves time by automating repetitive tasks. It increases efficiency by speeding up prototyping. It helps developers focus on solving higher order problems. If you think of it, um, in the past, when somebody needed a prototype, they would have to come to engineering, make sure the resources are available, prioritization, and then eventually getting a prototype built. Today, even a person with some technical understanding and half technical knowledge can at least be build an okay working prototype with the help of AI based code generation. And it is pretty transformative. It's helping people a lot who are actually in the field, in sales, analytics, and they don't need to be like a strong backend developer or a strong front end developer to be able to build something simple enough that they can use to demo. Um, it definitely is used a lot for efficiency, right? Repetitive coding tasks or any manual tasks can be very, very easily automated with help of AI. Skill augmentation, this is very useful for junior developers as it can act like an assistant and guide them through common patterns of coding, standards of coding, a lot of things. Like it was pretty common when I started my career that I would basically write code and then I would go for a code review to some senior developer and he would point out like 10 mistakes that I didn't know because I didn't have enough experience. And then I would come back and then implement it and go back. With help of AI, you can actually save so much time if the model can help train on a lot of basic stuff um, to the junior developer, and it can point it out as the developer is coding. Error reduction. Some AI models can also help catching simple errors, some boilerplate issues in the early draft of the code itself. So you can definitely reduce a lot of obvious mistakes. Um, so let's go and see. So I have a fun question for you all here. Uh, why does AI debug faster than humans? Just type in some replies in the chat. I'll monitor it. I just want to see what you guys can come up with. It's not a trick question. It's just a silly fun question. Um, well, it does not blame the user. The reason AI is actually very, very good at um, doing anything is because it does not cross question. You can ask it to do anything and it is not going to ask anything. It's just going to execute it. Whether it's right or wrong, whether it is of good quality or not, it doesn't matter. Suresh Kumar said access to vast training data. Yes, yes, you're right. This is, but I was just expecting like a fun answer here. But anyways, so let's move on. So let's talk about the practical constraints. Well, the potential of AI is immense, right? AI-driven code generation has its limitations. For instance, these tools often lack like the project-specific or domain-specific context, which can lead to code that doesn't fully integrate with your existing systems. I work in health tech. It's a heavily regulated, high compliance industry. When you generate code, um, a lot of times it might not follow the compliance standards or the data security standards that it is supposed to follow. And it can do pretty interesting things when you try to integrate that. Security is another major concerns. AI models might generate code that is efficient but vulnerable to attacks. And I have specific examples I'll go for these, which are probably going to get you deeper understanding of it. Um, Additionally, reliance on well-crafted prompts can sometimes also make this process very difficult. Like if your prompt is not specific enough, it would generate an answer which would not be your desired outcome. Um, Licensing and IP concerns are also something. So AI is trained on this vast data sets, right? Like we talked about, and these data sets can have so even open source code, right? When you use it for educational and research purposes, has different types of licensing needs and it is allowed. But if you're using it for commercial use in a commercial software, then the licensing works differently in some cases. And those are the areas where AI does not really able to really navigate, and it would generate code that can cause some legal troubles. Integration and maintenance is extremely difficult, especially for large enterprise applications. When you're generating code, you have to make sure that it is easy to integrate and maintain, and AI has a lot of limitations there. There is a fun one, which I didn't add a bullet point here, is AI developers. AI can also generate a lot of incorrect code. Developers have reported instances where AI confidently provides code snippets that are syntactically correct but fundamentally flawed. AI does show tendency to fabricate information rather than provide accurate responses. And it's called AI hallucinations. Read about it, and you might have already seen a lot of stories about it. And there are some really funny instances that I've read, but it is on a serious note, it can cause some serious complications in a production environment. Um, so let's go through some of these examples. So the contextual understanding. So for an example, I have just created some examples, some I picked from internet, is so that it's easy. But like this is a simple one. AI generated a schema that does not match the actual database. So when writing a function, now if the prompt is not specific, AI can generate everything for you. And in this instance, it also created a table for that specific order, which was already existing schema, but it did not really understand because it did not have full context of the project, and it actually generated a new table with a completely different schema. In such instances, manual updates are required and to kind of make sure that AI aligns with the generated schema. Um, Here is another one, security concerns. Uh, Weak password hashing. So when AI was asked in this case to encrypt a password, it basically used MD5 hashing algorithm, which is a bit outdated. And if your prompt engineering does not provide like very specific direction, then it can do mistakes like this. That's why the manual review of the output of AI generated code becomes extremely, extremely important. Here's another one, which is dependency on prompt. Now, in this case, if you provide a really vague prompt, AI will provide some output. It is not going to cross question it like a human. So in this instance, if you say create an inventory system, it is going to go ahead and provide you like some code, whether it makes sense or not. So in this case, it just added two functions, add item, list inventory. But that's about it. Uh, if a real human had to do it, he would have asked cross questions like, how do you want to use it? What is the scale, right? How many, what is the size of files you expect to be put in inventory? Like basic things. AI would not follow that. And that comes to another point. It's like, and I'll come to that performance in a separate example, but AI can write code, but it can be extremely inefficient. So without specific stack, database, specific details about features, AI can generate overly simplistic or overly complicated code actually in some instances. Um, so performance issue, right? AI can generate a code for you, does not mean it would be the most efficient code. For an example, in this case, if AI is asked to kind of do sorting or write a sorting function, it just went and wrote bubble sort. Now, We all know from the basics of R data structures and algorithms classes that bubble sort, although works and is simplest to implement, is also the least performant when it comes to performance and optimality. Um, a seasoned developer would know these things and would never write a bubble sort algorithm in a production level code. And that's the kind of places where AI does need validations. Constraints and examples. Another one is the one that I was talking about is fabrication of information. AI can blindly trusting AI always comes with its risk, especially with hallucinations like we talked about. It can come up with completely fabricated information and code. API endpoints. AI can fabricate the API URL, which doesn't even exist. So if you ask it to write a certain app or an API, sorry, it can completely come up with a made up endpoint URL. And you can waste a lot of time investigating it in a production why your code is not working. Um, Non-existing functions and libraries. This is pretty common when I generate Python code to read an Excel file into data frame. If you guys understand Python, Pandas has a method called read Excel, which allows you to load the Excel file, read the Excel file. The AI generated code, which was mostly correct, but the API or the function it called was load Excel. So it looks correct on the surface when you read it, but there is no such method as load Excel. So it can make up stuff when it doesn't know. Fabricated document of API details. Um, this is also very interesting. It can save functions in an API documentation that never exist, and you can spend a lot of times troubleshooting them and debugging them. False claims in commented explanation. So if you ask like it to describe, so say example, write a sorting algorithm and comment on its efficiency. um, it is pretty amazing because it's a GPT. It can completely exaggerate on the efficiency. Like it can write some really big weasel words like, "Oh, this is the most efficient way to uh, do a certain task," or stuff like that. Again, which is um, confusing and also sometimes completely false. Um, so, what are the challenges for developers here? So, we talked about a lot of these constraints. So, challenges is over reliance on uh, AI can actually lead to skill degradation. This graphic kind of depicts that. Even though it feels like you can generate code in 5 minutes, you can spend like a whole day debugging it. Um, complex it debugging AI generated can be very, very tricky. Moreover, integrating this code into complex enterprise system often requires significant manual intervention. Um, so, and then there's performance optimization gaps that you would do normally in a production code that you would not get at least by AI in most cases, and that needs manual review. So, what are the strategies to mitigate this? Uh, so the first step to treat is the first step is to treat AI generated code as a draft always. Review and test it thoroughly before integrating it. Another area is ensuring that you evaluate the tools that you're going to use or right for your business need. There are so many AI models available today, and they all are really good in some areas and they all lack in the other. You have to ensure that you're choosing the right tools. Um, Prompt engineering. Learning how to write precise and detailed prompts is a critical skill for developers using these tools. Doing security testing. Finally, developer needs to continuously upskill themselves and adapt to workflows rather than become overly dependent on the um, technology. So, how does the road ahead look like? The future is promising, right? We have seen a lot of advancements. AI models are becoming more specialized with domain specific capabilities. We are also seeing the integration of AI tools with CI/CD pipelines, making AI core part of DevOps. But however, like we must do also consider the ethical and legal implications of using these tools as they become more prevalent in the market space. So, closing thoughts. In conclusion, AI driven code generation is a powerful tool that can augment your work capabilities, but it is not a silver bullet. Adapting to this technology responsibly requires balancing its strengths with its constraints. As developers and leaders in our roles, it is important that we ensure that these tools are used effectively, securely, and ethically. Um, with that, I want to thank you for being an amazing audience. I feel um, I have left my LinkedIn and email here on this slide. Feel free to connect with me on LinkedIn, reach out to me via email, um, or IMs on LinkedIn if I can be of any help in your process of learning or building careers in tech. With that, thank you so much.